Hi, everyone. So thanks for coming to the talk. This is joint work with Felix Eggers from Copenhagen Business School and Eric Reynoldson from Stanford University. So in this work, what we are trying to do is we're trying to explore if we can use LLMs to take part in online surveys and online experiments. And if we find that if they do a good job at taking part in surveys, we can potentially use this method and go back in time and make them take part in surveys in the past. So because the challenge with surveys is like you can collect data today, but you cannot go back and run a survey 20 years back, right? So it's not possible. And for that reason, I call this paper, as a time machine. So potentially, if we show that they work well at taking part in surveys, we can go back in time and create time series data. So let me first give you the context, in which we're trying to apply these methods. So a big chunk of my research agenda for the past 10 years is basically motivated by this fact that, we see the digital revolution all around us, except in, macroeconomic statistics like GDP, productivity, and so on. So, we spend a lot of time online every day. But if you look at the share of the information technology sector as a percentage of the overall economy, that share hasn't changed much. It has basically stayed the same for like the last 30, 40 years. And the reason for this is, we get a lot of benefits from using digital goods, but we are not necessarily spending a lot of money on these digital goods. So, you go and do a Google search, you're not spending 10 cents per search, right? You're basically doing it for free. So in my research, I've been trying to build metrics which capture not just the production side of the digital economy, but the benefit side or the welfare side. So I have, done a lot of work in the past, and we have built this new metric which we call GDP-B, where B stands for benefits. And the idea is, we have national statistics like GDP, productivity, and so on, which measure the production side of the economy. And here we are trying to measure the welfare side, to complement the existing system of national accounts. And the big, the way we do these measurements is by basically running lots of large-scale online choice experiments. And the idea here is, so for digital goods, there is no data on prices and quantities because you're not spending money on these things. So instead, what we do is we run, lots of online surveys, basically of this type, where we try to measure, how much do we have to pay you so that you stop using a particular digital good. So here, it's an example of an experiment I did with Facebook, where we recruit a random group of Facebook users, and then we offer them, these take it or leave it choices. So here, someone was randomly given $40, and they were asked to make a choice, if they will keep access to Facebook or give it up in exchange for $40. The price, the $40, is randomly varied across different users. So any given user gets like one price point. We also do this with an incentive compatible design. Some users may be randomly selected. And if they're selected, they're actually given cash if and only if, they actually deactivate Facebook and we verify it. And at the end of the time period, they get the cash. And what I find in previous work is, when we do these kinds of online choice experiments, the incentive compatibility matters quite a bit. If you do a simple hypothetical survey, valuations are much larger. When real money is on the table, valuations are smaller. So we do these kinds of surveys. We aggregate data from lots of users, with different price levels. And once you aggregate this data, we can start estimating demand curves. Of course, there are challenges with this method, the main challenge is it's quite expensive. I've used most of my research budget for several years now on recruiting human subjects and paying them. And especially if you want like representative, large-scale, high-quality data, it's quite expensive, And also these days, many of these respondents themselves are using LLMs. So the quality of the data is also questionable. And incentive compatibility gets challenging as well. In some cases, like for example, with Facebook, I could partner with the platform and make sure users who are selected actually give up the app in exchange for cash. We can do that sometimes without collaborations with platforms, but doing it at scale gets challenging. And then the other challenges, right, which I mentioned earlier, which is with these surveys and choice experiments, we can collect data today. But what is more interesting than the absolute levels is looking at changes over time. So, seeing, are these welfare gains from digital goods, are they increasing or decreasing? How do these numbers look like, in 2015 or 2020? So going back in time and creating time series data is not possible, right? Like if we are conducting like a new type of survey. So in this paper, we are basically motivated by several other research papers recently, which have basically shown that, in various contexts, LLMs seems to, produce responses consistent with economic theory and with human behavior. So many papers in this space. There also someone, on Twitter was like, asking, if why, the GDPB method, which we have, done, can we use LLMs, to take part in the survey? So someone else was also like, basically asking us to do it. So that's what we end up doing. So there's a lot of literature, showing that LLM seems to do quite well at taking part in experiments. So we basically see what happens when they take part in the sort of experiments we have been doing in our context. So the data is basically, so we have 8 waves of online survey data from 2016 to 2024, where we have measured, how much users value Facebook. So the example I just gave earlier, so we had these experiments where we basically recruit representative samples of US online population. We have 8 waves of data. And the first 2 waves of this data, the results of those waves I had published in an earlier paper, but the other waves are not, the data is not published and the results are not published, so it's not part of the training data. So we have data from humans, going back to 8 years, and then we use LLMs to basically create, similar data. So we take, LLM agents, and this is like, analysis we did last year, so the models are already outdated. But, so we take LLMs, we give them, a prompt, which is basically, explaining them what the choice experiment looks like. And then we create different personas, and each persona is basically matches the human respondent who took part, in a similar survey, in the human data. And then for each persona, for a specific year, we asked the LLM to make this exact choice which the humans made, like, would you keep access to Facebook or give it up in exchange for a certain cash offer? So we have data from humans, and then we use LLMs to basically take part in these same sorts of surveys for these 8 waves. So the prompt basically looks like this. So we, define the year in which we are doing the data collection. We explain incentive compatibility. So we tell the agents that, whatever choices you're making are consequential. It's not like it's like a cheap talk response. We also have some prompt explaining random utility theory, because that's the framework which we use to analyze, discrete choice data. And then, we create personas, with like, different demographics and Facebook usage matching the human subjects who took part in these experiments. And the cash offer, is basically the price which we are offering them, and they have to the LLMs have to make a choice, like, would you keep access to Facebook or give it up for this particular cash offer? So when we look at the results and compare, median valuations using human subjects and LLMs, what we find is LLMs do quite well. The median valuations of Facebook, are basically, not significantly different from each other, using the human data and using LLMs. And the demand curves, like using LLMs and human data, basically look quite similar as well. So here, we have demand curves for Facebook valuations. So x-axis is, percentage of people who choose to keep Facebook and reject the cash offer which we offer them. The y-axis is the cash offer which we are offering them. So demand curves, are downward sloping with humans and LLMs, and they look quite similar for all the 8 waves of data we have. So that's what we first find. So we first established that, like LLMs do a pretty good job at estimating valuations of Facebook. And now that we have shown that, we can try to see what happens if we go back in time. So this is what we find. So from 2016 to 2024, we have data from humans and LLMs, and the valuations are very similar. And using LLMs, we now go back in time and, make them take part in these experiments in like 2010, 2009, also going all the way back to 2004 when Facebook was created. So what we find is, so in 2004, like Facebook valuations were low, Facebook just got started. Over time, they keep on increasing. In 2010, it reaches the peak, it's probably, you may remember if you've been on Facebook for a while, like in 2010, I think we're, golden years of Facebook, where everyone was active, got a lot of value from it. And that's what we're seeing it here as well. And then later, it starts going down gradually. And then, Cambridge Analytica happens in around, 2015, 16, and we see that valuations drop. During the pandemic in 2020, the valuations seem to rise again, but then since then, again, they've been gradually dropping. So, one question which came up is, is this like a general thing which LLMs are capturing, or is this something specific to Facebook? So we do similar sorts of experiments for Instagram. And, what we find is, Instagram valuations look quite different. So Instagram, launched in 2010. Valuations start off low. Over time, they're increasing. Around 2017 or 18, Instagram valuations overtake Facebook valuations. But they're not necessarily falling since then. They have been, basically plateauing over time. Again, consistent with, what I have personally observed with my Instagram and Facebook usage. So potentially, we can also do this to extrapolate into the future, of course, with lots of assumptions, just doing a simple extrapolation. So basically making the LLMs, take part in Facebook valuation experiments for the future. What we find is by 2030, it probably will keep on declining and, and reach a much lower valuation. But again, these are a lot of assumptions involved here. So we do a few robustness checks, So first is, do we have to do this whole exercise of, creating different AI personas and then make them take part in experiments, or can we just directly ask it to say what, it thinks the overall Facebook valuation is? And what we find is directly asking doesn't necessarily work. It works fine for 2016 because that's the number which is in our paper. So, it just looks up our paper and the valuation works fine. But for the other years, directly asking it versus creating different personas and taking part in these experiments, the valuations look quite different. We also do some other analysis, playing around. If you remove the incentive compatible part of the text, what happens? So we have some text, telling the agent that the decisions are consequential. We also do some, other analysis where in one, condition, we tell them, the agents, that, the decisions are hypothetical. In another condition, we completely remove this particular aspect of the prompt. And what we find is, mentioning the incentive compatibility really matters. So, if we mention incentive compatibility, the valuation is around $53. If it's a purely hypothetical, it's like significantly overestimated, like almost $1,300. And if we completely omit the incentive compatibility part as well, the valuations seem to be quite higher. So the incentive compatibility text of the prompt seems to really matter. We also have a similar analysis, mentioning the random utility theory or not, and that seems to matter quite a bit as well. If we don't mention that in the text, valuations again are quite, higher. So to summarize, so we first demonstrate that LLMs seem to do quite well in taking part in these online choice experiments. The valuations, the median valuations for the overall population look similar. The demand curves also look similar. And potentially, using that, now we can create time series data going back in time. And this kind of a thing is not just useful for digital goods, but for non-market goods in general, where, data on prices are not really available. So for future work, I think one interesting thing to look at is to look at counterfactual scenarios in the past, for which data doesn't exist. So for example, there is a heated debate even today, should Facebook have been allowed to acquire Instagram in 2012? we don't see the world, in which Facebook didn't acquire Instagram. But potentially using LLMs, we could go back in time and see, how do valuations of Facebook and Instagram change if Facebook acquired Instagram and if Facebook didn't acquire Instagram. And potentially we could use these tools, they could be useful for regulators and in the litigation context to try to quantify, are users better off or worse off, because of some of these past decisions. So that's it. Yeah, thank you.
Really interesting. So I was thinking about doing this exercise. So one of the thoughts around LLMs being able to kind of predict things is like, are they going to be doing well in edge cases or paradigm shifts, which are not in their training data set?
Yeah.
So here, your demand curves where you had the ground truth look kind of similar to each other. There weren't these changes.
Yeah.
It makes me more convinced the fact that just asking it rather than using the individual agents gives you a different result. But in general, I'm kind of thinking like, if there was some event that's not in its training data set, like especially doing these counterfactual exercises, I'd have a little bit less confidence in this exercise.
Yeah. Fair point. Yeah. So I haven't done that yet, but I want to think more about it. But
But if you had something like where you in your private data set you had some sort of event, and then you saw that it predicted valuations in your private data set in response to the event, that would be super.
That would be Yes, Dave.
So really exciting stuff. Glad you're doing the time series. I guess I would encourage you to do not just the things that don't have prices, but do the things that do have prices. You don't have to pay for subjects anymore. Because, if you find that it's the case, for example, that real value added of things that aren't priced is growing at the same rate as the stuff that is in GDP, then that's a very interesting result. I don't think so, but we don't know until you try it. And I guess the other thing is, so where are we with regard to prompt engineering so that you can tell the AI not to look at your paper? Seen cases where AI will zero in on just one source, even though it has access to the world, and just say, "Oh, here's the truth." Can you do that?
Can definitely play around with that. That's possible. And your other suggestion also something would be, something we are trying to look at, for other, not just digital goods, but for other types of goods as well. And
Avi, I think it's good. One question I have in your modeling, in the real person world, there's constant change as far as the network is concerned, the usage patterns are concerned, that produces that affinity to that platform. How have you sort of replicated it with your LLMs? Is the network, kind of mimicking the same way, the depth and breadth of the networks or the usage patterns? Have you basically been able to mimic that in your synthetic LLM?
So when we create the personas, we basically give them whatever the human subjects' usage and network sizes were to the AI agents. But that's the extent of mimicking we did. I think we could...
Not across time. You didn't mimic it across time.
So for the 8 years of human data we had, we give them exactly what the users had. When we do extrapolations, we have to make assumptions and, looking at publicly available data and trying to, there isn't actually good data out there on what was the network size of users on Facebook in 2012. But we have, we make some assumptions there. But yes, that is a good point, which is, for when we don't have data from humans, we have to make assumptions when we create the personas.
Thank you very much.